times RV. I notice there are a lot of common factors I can pull it out. All right? I have 16. I also have a sine u. I should be able to pull out a 16 sine u, which means the inside is going to be sine u cosine v, sine u, sine v, and cosine u. Okay? Then computing the length will be much, much easier. So the length of the Ru prime times Rv prime is going to be exactly 16 sine u multiply the length of this vector. All right? If you have any constant multiply by vector, the length is that constant multiply the length of the vector here. The length of this vector is equal to 1. Because this x, y, z is lining on a sphere with radius 1, essentially. Okay? So the length is just 16 times sine u. If you don't believe me, you can square this one, square that one, you can cancel cosine with sine uv, and plus the cosine u, you're going to get 1. So the length of this vector is equal to 1. So in the end, I'm going to do 0 to pi half, 0 to 2 pi. Or if you prefer, let's do u in the inside. So it's going to be 0, 2 pi, 0 to pi half. I need to replace x, y by u and v here. So it's going to be 3, 4 sine u cosine v squared plus 3, 4 sine u sine v squared. Right? This is just a 3x squared plus 3y squared. Then multiply the length of this guy, which is multiplied by 16 sine u. So u goes inside, v goes outside, du dv. Okay? So if you have sine and cosine, don't be scared. A lot of squares will be canceled out in the end. So this one, cosine squared plus sine squared, v will be canceled. So essentially, I'm getting 0 to 2 pi, 0 to pi half. I have a 16 times 3, so it's 48. In the end, I have a sine square u coming from the big bracket multiplied by 16 sine u du dv. Okay? Which means I need to compute 48 times 16 from 0 to 2 pi, from 0 to pi half, sine cubed u du dv. That's the one in the end that you need to evaluate. Okay? Which in the end is going to give you 1024 pi. I'm talking about this problem in class mainly because I don't like it. As I said, in the online homework, I'm really annoyed about setting this kind of problems. It takes a long time. It's not the main focus of the course. But one thing I do want you to be completely free, completely sure of what we're doing here is the step before. Every step before taking the double integral, you should be very, very familiar with how to set up the parametric equation for a sphere, how to compute the two tangent vectors, and do the cross product to find the normal vector, and how do I evaluate the length of the normal vector. The step from this step above has to be what you are focusing on. So next week, it will be the next week of, will be the last week of lectures. So we're going to cover 15.7 and 8, which will be completely based upon the surface integral. So definitely review and preview.